Alright, good morning my physics friends. We're going to do another angled launch problem today. This one is a little different. The ground that the object is going to start and end on is level, so it's not a different landing and launch height. So looking at my problem, I know that it's going to ball here. It's a golf ball, and it gets hit at an angle of 65 degrees at 17 meters per second, and I want to know if it's going to go in the hole, which is 322 meters away. So I know that the ball is going to rise up, and I'm hoping that it's going to go into the hole. So two things I want to know is, will it go 322 meters? And I also want to know how high it went. What was the maximum height? So the first thing I should do, besides having a little sketch, is to make my two-column given chart in my x and y direction, and fill in what I know. In the a direction, acceleration is 0, y is negative 9.8. Let's see. I know the initial velocities. I will have to compute them. And so for my little trig triangle here, v0y, v0x, and v0, so this is 65 degrees. So for v0y, that's going to be v0 times the sine of theta, and so that's 17 times the sine of 65 degrees. So v0y equals 15.4. And for v0x, I'm going to use cosine because it's the adjacent side. So v0x is equal to v0 times the cosine of theta, or 17 times the cosine of 65 degrees. So v0x is equal to 7.2 meters per second. 7.2 meters per second. Okay. All right. So, and that's really all I know here right now. So the first thing I might actually find out is how high it went. Because I do know something special about the maximum height. At that position, I know that Vy is going to be 0. And if I know that Vy is going to be 0 at the peak, and if I claim that the ground for here is 0, then I can find out how high it went. And then I can also find out the time it took to get to the peak. So let's start there. So if I use, let's see, here are my equations. V equals V naught plus AT. S is equal to S naught plus V0T plus 1/2 AT squared. And V squared equals V naught squared plus 2A delta S. If I use this third equation, I can find out how high it went because I'd be solving for this delta S. So I have V squared is equal to V naught squared plus 2A delta S. And then this would be 0 at the peak is equal to 15.4 squared plus 2 times negative 9.8 delta S. So 15.4 squared, that's 237.2 plus a negative 19.6 delta S. So I'm going to subtract 237.2, and that equals negative 19.6 delta S, and divide. So I get delta S is equal to 12.1 meters. That's how high it went before it fell back down. Now I can also use that height to determine the time it took to rise to the peak. Because the path of this ball is symmetrical, that tells me that's half the total time the ball is in air. And I need the total time to find this final position in the x direction. So let's find the time to the peak. So time to the peak Well, I have all these pieces of information. The easiest one I can use is the first equation. V is equal to V naught plus AT. V being 0 at the peak, V naught being 15.4, A is negative 9.8, and then time. Okay. So then I would get negative 15.4 divided by negative 9.8. That equals T. And I end up with the time to the peak is 1.57 seconds. Okay. So again, that's here. Because the path is symmetrical, I can multiply that time by 2, and that will give me the total time in error. So 1.57 times 2 gives me 3.14 seconds. Hey, that's pi. 3.14 seconds is the total time the golf ball is in air. And now I have enough information in this X column to see if I'm going to go the 322 meters. So let's find out. This one I'm going to use the S equals S naught equation because I'm solving for that final position. And I don't know the final velocity in the X direction. So I have S is equal to S naught plus V0t plus 1/2 A t squared. And then in the X direction, the acceleration is 0, so this whole term drops out. And I'm claiming the initial position is 0, so that term drops out. So my equation ends up being S is equal to V0t. And so S is equal to 7.2 times 3.14 seconds. And I get 22.6 meters. So this is much less than 322 meters. So I really missed the hole. I need to work on my golf game. Okay. So this is an example of an angled launch problem where the ground is level, the landing and the takeoff spot are the same height, and there's lots of pieces of information you can find out here. Remember to use that peak height to help you, and you can solve it many different ways.